Now we're going to look at another strategy for simplifying trigonometric expressions. Specifically, we're going to be talking about how to deal with fractions. When you have multiple fractions that are being added or subtracted together, you have to remember that you need a common denominator for that. So for example, if you had 1/2 plus 1/3, we can't add these together unless they have a common denominator. So we multiply the fraction on the left by 3/3 and the fraction on the right by 2/2. Basically, I'm taking the denominator of the other fraction and multiplying it across. And what happens is you end up with two different fractions that have the same denominator, and then you only add or subtract the numbers on top. So we end up combining the two fractions we had originally into one combined fraction. That's going to be the same concept we'll be doing here. We're going to get a common denominator and try combining them into one fraction. So now we have two much uglier examples of fractions, but the same concept we just looked at for 1/2 and 1/3 will be applied to 1/cosecant of x plus 1 and 1/cosecant of x minus 1. So to start off, take the denominator cosecant of x minus 1 and multiply it on the top and bottom of the other fraction. Now the reason I can do this by multiplying top and bottom by the same thing is because I'm actually multiplying by 1. If I take a number and divide it by itself, then that's actually equal to 1. So multiplying by 1 does not change the value of this fraction here. And the same thing for the other one, when I multiply the top and bottom of this fraction on the right by cosecant of x plus 1 over cosecant of x plus 1, then again I'm multiplying by 1, so we're not changing the value of the fraction, we're only changing what it looks like once we get through the distribution part. So here on the fraction on the left, make sure you're actually distributing this out. I'm going to be doing 1 times cosecant of x minus 1. This is pretty easy since my numerator is a 1 in this case, but do be careful when you have other stuff up there, especially if you have two terms that you have to FOIL all the way out. So 1 times cosecant of x and 1 times -1. And for the fraction on the right, before I do the distribution, I'm actually going to change this to a plus sign in between, and then put the negative here in the numerator of the fraction. So this is the same thing. Adding a negative is the same as subtraction, but this way I'm going to make sure I don't accidentally forget to distribute -1 times cosecant of x and -1 times 1. So that's just to be careful about the distribution. I don't want to accidentally forget that the negative sign is in there in the middle of the fraction. So I just moved it over for convenience. Now in the denominator, I'm distributing this as well. So I have cosecant of x minus 1 times cosecant of x plus 1. You can use parentheses and distribute this out or FOIL it if that's how you learned it. However, a nice shortcut you can use in this case is to recognize that we have a minus b times a plus b. So this actually matches the difference of squares, which means my answer should be a squared minus b squared. So that'll save you time when you start to recognize those difference of squares steps. Usually we go the opposite way. We factor it from a squared minus b squared, but it's good to know both ways in this situation. Now that I've gotten my one fraction combined into one common denominator, I can start combining the like terms. So I have a positive cosecant of x and a negative cosecant of x, which would cancel just like x minus x. But the -1 minus 1 more, that does not cancel. Be careful on that. This will end up being -2. So now I have -2 over cosecant squared of x minus 1. Now I've paused for a moment here to show you that I do have a Pythagorean identity I'm going to be able to apply. I saw that I had a function squared and either a plus or a minus 1, so I looked at this identity in particular, and I saw that if I subtract 1 from both sides of the equal symbol, I'll end up with cotangent squared of x is equal to cosecant squared of x minus 1. And cosecant squared minus 1 is what I have here, so I can replace all of that with cotangent squared. And then another useful thing to know here is that cotangent and tangent are reciprocals of each other. So by having cotangent squared in the bottom of the fraction, you can actually flip that to be tangent in the numerator instead. The -2 is not changing, it's just the cotangent that was in the bottom that's flipping. And again, that's coming from the fact that 1 over cotangent is equal to tangent of x. So if you want to think of it as a substitution, you can, or just make sure you know which functions are reciprocals of each other, so that when you have one in the bottom of the fraction bar, you can write the reciprocal one on the top instead. It doesn't move anything else though, that's why the -2 stayed in the numerator, and I just didn't write the over 1 part. So here we have a much more simplified answer compared to our original fractions that were being added and subtracted. Here's another example of working with multiple fractions, because I know these are tricky. So when you are adding or subtracting fractions, it's often the case that you need to combine them into one fraction. So I'm taking the denominator on the right-hand side, sine of x, and I'm going to multiply that on top and bottom over here. And the other way around, I have 1 plus cosine for the denominator on the left fraction. I'm going to multiply that by top and bottom on the right-hand side. So since I'm multiplying it on top and bottom, I'm multiplying by 1, which means I'm not changing the value of these fractions. So when I do sine times sine, that's going to be sine squared of x. And then this is a case where I have two terms being multiplied by two terms. So you do want to be careful about distributing this out the whole way. So 1 times 1. And then if you do the outside and the inside product, this should give you 2 cosine of x, because I'm doing cosine of x plus cosine of x. And the last product, cosine times cosine, is cosine squared. You may have also learned how to do that product by saying if you have a plus b times a plus b, it's a squared plus 2ab plus b squared. That's another formula that can help you save a little bit of time on distributing out that whole thing. So now I have my numerator set up. In the denominator, I'm actually not going to distribute this part. I want to try and leave it separately as sine of x times 1 plus cosine of x for a second. Because what I'm going to hope will happen is that when I combine some of the like terms, maybe do a Pythagorean identity on top, I'm hoping that at some point I'll be able to cancel some of the stuff I have in the bottom. So I'm only distributing on top. And then now I see that I have a sine squared plus a cosine squared. Well, you can rearrange these to get them closer together if you want. You can write sine squared plus cosine squared, because the order of addition does not matter. As long as I still have all the stuff being added here, plus 1 plus 2 cosine of x, then the order that I add these terms in does not change my answer. And I haven't done anything to the denominator yet. But the reason I rearrange those is so that hopefully you would recognize that right here now I have a sine squared plus a cosine squared. And that's one of the Pythagorean identities that we went over on the last video. So this whole thing can be replaced with 1, and then 1 plus 1 is 2. So I just combine the like terms. If this is all 1 and I have another plus 1, now I have 2 plus 2 cosine of x. And we're almost done. There's a little bit more I can do here, because like I said, I was hoping I'd be able to factor and cancel something out. And I do have a GCF on top. Both of these terms, my 2 and my 2 times cosine of x, they both have a 2 in them, so I can factor that out. I'm getting a little low on space, so I'm going to drag this back up here to the top. So I'm factoring out the GCF in the numerator, which will be 2 times 1 plus cosine of x. And I'm still not doing anything on the bottom yet. But I did just create that matching binomial, 1 plus cosine of x. So now that I have 1 plus cosine of x on top and bottom, those two things would cancel out. Now, one of the reasons I can do this is because I don't have anything else being added or subtracted up here. I just have one product on top and one product on the bottom. So those matching factors cancel in this case, which leaves me with just 2 over sine of x. And instead of writing this as a fraction, as long as you know that sine is the reciprocal of cosecant, then instead of writing sine in the bottom of the fraction, I can write cosecant on top. The 2 is staying on top. I'm just writing this over 1, but I'm not actually writing the over 1 part because that's unnecessary. So I'm leaving it as 2 cosecant of x because sine and cosecant are reciprocals. So this is a tougher problem. It did have more steps. There was a lot of factoring, using Pythagorean identities, canceling. You have to be very careful about your work. Sometimes you may find yourself getting kind of backed into a corner or taking a step that didn't seem to make things easier. And if that's the case, you may just want to go back to an earlier step and say, well, could I have tried something different? Maybe I didn't need to distribute sine times 1 plus cosine, or maybe you used a different identity that when you plugged it in, you ended up with something uglier. So sometimes you just need to go back and try a different step until you do see things cancel out nicely, because you should always get something pretty simple at the end for these simplifying problems. So that's it for the notes. Thank you, guys.